Hi all, today we discuss the second order partial derivatives of a function. If we consider a function z equal to f of xy, and we have discussed what is a partial derivative, df by dx. This is obtained by differentiating this function f of xy by taking y terms are constants or y is a constant. So if we have f of xy is this manner, f of xy is equal to 5y square plus xy. Df by dx is defined as the derivative of this y 5y square plus xy with respect to x by taking this y terms are constant. Okay, so the derivative of this 5y square with respect to x is 0, so that will be 0 plus and the derivative of xy is derivative of xy is x derivative of x, that is 1 into y, because this y is a constant. Okay, this is like some 2x 3x etc. So this is yx, the derivative of yx is y itself. So df by dx is nothing but y. So this is the meaning of partial derivative. Now if you need to differentiate this with respect to x again, you need to write this d by dx of df by dx again. So you need to suppose we need to differentiate with respect to this function with respect to x again, so that will give the 0 because there is no x in this expression, so this can be taken as a constant, then the derivative of that constant with respect to x is 0. Therefore this is what we call the second order partial derivatives. Okay, so this is denoted by the symbol d squared f divided by dx square. Okay, so this is the one of the second order partial derivatives of the function f of xy. Okay, so once you immediately after finding this df by dx, you can perform d by dy of this function again. Okay, so once you differentiate this df by dx with respect to y, you can write d by dy of df by dx. This can also be evaluated, so that will give 1. Okay, these are in their different quantities because df by dx is y, and if you differentiate this with y by taking x as constant, you can get there is no x in fact here, so that is 1. Okay, so d by dy of df by dx, okay, that will give 1. Okay, in this case we write this as d squared f dy dx. The meaning of this is this one. Okay, first you differentiate this f with respect to x by taking y as a constant, then differentiate the resultant function with respect to y with taking this x as constant. Okay, so once you evaluate, so these are different possibilities for taking the second order partial derivatives. Okay, similarly you can take another you can produce another second order partial derivatives by taking df by dy first. When you consider the f of xy this and differentiate that with respect to y first by taking x as a constant. Okay, so this will give this 10y plus x. When you differentiate this function with respect to y taking x as a constant, you can write the derivative of 5y square is 5 into 2 times y, that is 10y, plus derivative of xy. Derivative of xy is y, since this x is a derivative of xy is x with respect. When you differentiate with respect to y, you can get this taking as x as a constant. This is like 2y, 3y, etc. So the derivative of this term will be x. So this is one way of writing another partial derivative of this f with respect to y. Now when you consider this derivative and differentiate this with respect to y again, dy by dy of df by dy. Okay, so that will give the derivative of this function with respect to y again. So that is 10 plus 0 because the derivative of x is 0 because x is taken as constant here. So that will give 10. So this is represented by d squared f by dy that can be written as dy squared. Okay, if these two variables are same, you can write it as dy square. Okay, on the other way, you can differentiate this with respect to x. So that will give df by dx of d by dx of, that is d by dx of df by dy. This will give the derivative of this function with respect to x. Okay, the derivative of this function with respect to x is, the first term will be 0 and second term, the derivative of the second term will be 1. Okay, because this is 10y, so that is taken as constant. So that is the derivative of that term is 0, and this will be 0 plus 1, so that is equal to 1. And this is represented by d squared f by dx dy. This shows that the derivative of the function f, okay, with respect to y first by taking x as a constant, then take the derivative of that quantity with respect to x by taking y as a constant. Okay, so these are the these are the only possible second order partial derivatives defined for a function z equal to f of xy. Okay, so these are the second order partial derivatives of f. The first one is d square f by dx square, then d square f by dy square. Similarly, you can write d square f by dy dx, then d square f by dy dx dy. So this stands for the derivative of f with respect to y first by taking x as a constant, then take the derivative of the resultant function with respect to x by taking y as a constant. Okay, first you in order to evaluate this expression, you need to first differentiate the f with respect to y first. Okay, now we start discussing the questions and problems on second order partial derivatives. First problem is, if f of xy is equal to x cos y plus y e raised to x, and find all partial second order partial derivative of this. So these are the only possible second order partial derivatives: dou square f by dou x square, dou square f by dou y dou x, d square f by dy square, d square f by dx dy. So first we can evaluate, in order to find the partial derivatives, second order partial derivative, we need to evaluate all the first derivative of, in order to evaluate the second order partial derivative, we need to first evaluate the first order partial derivatives. So that is, first one is d square f by df by dx first, then after that we can evaluate d squared f by dx squared. So what is df by dx? Df by dx is the derivative of the given function with respect to x by taking y as a constant. So when you consider the derivative with respect to x, you need to consider this y is this term is constant and this term is constant. Okay, these two terms are constant. So the derivative is derivative of x cos y. Derivative of x is 1, then constant y is here, plus, and y is constant, so you can write it as y here, and derivative of e raised to x. E raised to x is derivative of e raised to x is e raised to x itself. So this is the first order partial derivative of f with respect to x. Similarly, you can evaluate df by dy. That is obtained by differentiating the given function with respect to y taking x as a constant. So that is x into derivative of cos y. Derivative of cos y is minus sin y, so you can write it as minus sin y, plus the derivative of y e raised to x. Derivative of y e raised to x with respect to y, so that will be e raised to x is a constant, then derivative of y is 1 here, so you can put it as this times 1. So that is minus x sin y plus e raised to x. So this is the derivative of f with respect to y. Now you can start evaluating the second order partial derivatives. The first one is d squared f by dx squared. So this is equal to d by dx of df by dx. So that is d by dx of, what is df by dx? Df by dx is this one, cos y plus y e raised to x. That means we need to differentiate this function with respect to x again. So that will give 0 plus derivative of cos y with respect to x is 0, and derivative of this function with respect to x, that will be y times e raised to x again. So that is equal to y times e raised to x. Now we can evaluate d square f by dy dx, d square f by dy dx. So this is this notation stands for d by dy of df by dx. That means you need to differentiate this with respect to y again. So that is equal to d by dy of cos y plus y e raised to x. When you differentiate this with respect to y, the first term will be minus sin y, and derivative by since this is a x term is a constant, then you can write it as this time e raised to x into 1. Okay, so e raised to x is a constant, then derivative of y with respect to y is 1, so that will give, that is equal to minus sin y plus e raised to x. So this is the d squared f by dy dx. Now you evaluate d square f by dy square. D squared f by dy square, that is equal to d by dy of df by dy. Okay, that is d by dy of, what is df by dy? Df by dy is this one, this function, minus x times sin y plus e raised to x. That is equal to, this is d by dy of this function as since minus x is a constant, so you can write it as minus x, and derivative of sin y is cos y plus derivative of this e raised to x with respect to y is 0, so that will give minus x cos y. Now the last one is d square f by dx dy. So this is obtained by differentiating df by dy with respect to x. That is df by dy, that is equal to d by dx of minus x sin y plus e raised to x. So differentiate with respect to x again. Then y is a constant, so minus sin y is a constant, and derivative of x is 1, so this times 1 plus derivative e raised to x is e raised to x itself. So this will give minus sin y plus e raised to x. This is the derivative of second order partial derivative of f with respect to x and y. So these are the four partial derivatives, second order partial derivative of this f of xy. Now we have some exercise problems. Consider these problems as your practice problems. Find all second order partial derivatives of the following functions. So once you consider the question number 1, you need to evaluate those d square f by dx square, d square f by dx dy, d square f by dy dx, d square f by dy square. When you consider the last problem, you must evaluate d square s by dx squared, d square s by dx dy, d squared s by dy dx, and so on. Okay, so these are the practice problems. Now we can wind up today's class with one remark. When you consider in this remark, I would like to introduce new notation for these second order and first order partial derivatives. Once you consider df by dx, this is the partial derivative of f with respect to x. So this is denoted by fx, f suffix x. Similarly, df by dy, partial derivative of f with respect to y, is denoted by fy. Now you have four second order partial derivatives. d squared f by d x squared. This is obtained by d square d by dx of uh, df by dx. So this is d by dx of df by df is the partial derivative of f with respect to x is denoted by this symbol. So I write it as fx here. And derivative of some function with partial derivative of a function with respect to x is denoted by this symbol. Using this notation again, we can write it as this is fx x, derivative of this function with respect to x, and it is termed as fxx. So this stands for d squared f by dx squared. Similarly, the similar argument follows d squared f by dx dy dx dy dx. So the meaning of this is d by dy of df by dx. So this is d by dy of this function. This is denoted as fx. So this is if you use this notation, d by dy of f, that is denoted by fy. So this is fxy. So this is nothing but fxy. Okay, so this is another notation for d square f by dy dx. Here the order is dy dx. So first differentiate with respect to x, then with respect to y. So you must note that here the order is different. So if you about to evaluate this f of xy, you need to differentiate this f with respect to x first, then y. Okay, here the order is from the left to right. Okay, here the order is first you differentiate with respect to x, then with respect to y. So from the right to left. Similarly, d squared f by dy squared. So what is the notation? This is d by dy of df by dy, and df by dy is fy. So this is d by dy of fy. So this is fy of y, that is equal to fyy. Similarly, d squared f by d x dy, that is d by dx of df by dy, that is d by dx of fy. So that is equal to fy of x, that is equal to fyx. Okay, so these are the four alternative notations for these second order partial derivatives for a function f, where f is z is f of xy. Okay, so using this notation, you need to evaluate all the second order partial derivatives. Say f xx, evaluate fxx, fyy, fxy, and fyx. So in order to evaluate fyx, you need to differentiate f with respect to y first, then x. Okay, so this is the order of the derivatives. Thank you.